Notice that there are several additional parts to this question. Wow. My question, as you can clearly see, doesn't tell me how many parts it is, so I just thought that was the answer. All right, so it said determine if the following statement is true or false. If there is a clearance for 95% of males, there will certainly be a clearance for all women in the bottom 5%. Now let's think about this. Of course this is true. If this is the upper echelon of men, this is the men's data. If we start looking at the women, and the women's represent the bottom 5%, where the area up underneath this curve is 5%, surely it'll work for them. And it doesn't have anything to do with, hey, men are taller and women are this or that and the other. I mean, it could go to that if you really wanted to use common sense, but if it's clearance for 95% of males, surely it's going to be clearance for the bottom 5% of women. The statement is true. It's greater than the 5th percentile for women. It's clear. All right, the next part of the question says the author is writing this exercise at a table with a clearance of 23.4 inches above the floor. What percentage of men fit this table? All right, so again, we found the x value. X minus the mean divided by the standard deviation equals the z-score. Now again, if I wanted to calculate this to get the 24.5, what I would get would be x minus the mean of 21.5 divided by the standard deviation of men of 1.2 is equal to that 1.645 value that I found on the table. Or maybe I'll just put a 5 there. Now I want to prove it to you that it is the answer that we got right here. So I do 1.2 times 1.65, and then I have that 21 that I'm going to add to this, so 21.5 gets added to this, and lo and behold, I got 23.48, which is still 23.5. Same answer that I got. So what does the second part ask us to do? Get that out of the way. The second part says that the author is sitting at a table with a clearance of 23.4 inches above the floor. What percentage of men fit this table? All right, so 23.4 minus the mean, 21.5, divided by the standard deviation. What is this z-score? Because we'll find that z-score right on the table, on this normal curve. The z-score for which, that represents 23.4. So using our handy dandy calculator, let's find it. Clear this out. 23.4, and again, this is a random number the author came up with, minus 21.5 divided by the standard deviation of 1.2 equals this value, 1.58. So of course I look on my table for 1.58, and that's going to give me the percent of people that are this number or less. So 1.58 goes along with 0.9429. So 0.9429. Now if I wrote that as a percentage, that's going to give me 94.29%. So as a percentage, it's 94.29%. Just move the decimal to the right 2 places. That's all you do there. So 94.29. Now you'll get a different value if you use StatCrunch. You get a different value if you use your calculator, but the computer has all these values, and they will accept them all. Now, what percentage of women fit this table? All right, so this is a table clearance. What do we have for the mean information for women? That's what we're going to use. So 23.4 is the clearance height. The mean for women, I believe, is 19.2. So 19.2. And the standard deviation is 1.1. You get the gist of it. Use the z-scores. Let's see what you come up with.